So in our next problem, we're going to have a vertex of an angle lying inside of a circle. So again, I'm going to start with my circle, and I have the vertex A of some angle here, angle BAC, lying inside this circle. And I want to prove that the measure of this angle is equal to half the sum of the angle measures of the arc of the circle, confined inside this angle and inside the angle symmetric to it through vertex A. So basically what that means is that we're extending these two chords, and we want to show that this angle A, right, which is the same as this angle, we would refer to that as a reflex angle. So we want to show the measure of either one of those angles is equal to the sum of the two intercepted arcs. So again, I want to give these things names. And so we're trying to show that angle BAC is equal to half the sum of the measure of arc BC and the measure of arc DE, right? All right, so we're going to do just a sort of similar trick to what we did in the last problem. I'm going to put in an inscribed angle. And so this is going to be helpful for a number of reasons. So now, what can we say? So just like in our last problem, where I have this angle, well, I'm going to actually state the simpler theorem. So we used the fact that the sum of the angles in a triangle is 180 degrees, and the sum of the angles in a linear pair is 180 degrees. And we use that to show what is actually more simply stated as the exterior angle theorem, which is what I'm going to apply here. And so the exterior angle theorem tells us that an exterior angle, which is an angle that is in a linear pair with one of the angles of a triangle, is equal to the sum of the two remote interior angles. So basically what that tells us is that angle BAC, which is our exterior angle, is equal to the sum of angle, this angle at vertex E, which I'm going to call angle BEC. I could call it AEC also, but I want to call it BEC here. So that's equal to that angle, plus this other angle at vertex C, which I could call ACE. I'm going to call it angle DCE. Okay, and the reason I wanted to name those angles that particular way is because both angle BEC and angle DCE are inscribed angles, right? And we know that the measure of an inscribed angle is half the measure of its intercepted arc. So I know that angle BEC is equal to half the measure of arc BC, and I know that angle DCE is equal to half the measure of arc DE. And so combining these and substituting, we can now say that angle BAC is half the measure of arc BC plus half the measure of arc DE, and factoring out a half, I get that the measure of angle BAC is half the sum of its two intercepted arcs. So BC plus DE. And again, these two statements are because of the fact that those are inscribed angles. So half the intercepted arc. And we've shown exactly what we were trying to.